So in this video I want to go through differentiating some of these natural log functions. So with each of these examples, there's a few things to keep in mind. First of all, the fact that the derivative of the natural log of x is 1 over x. Now in each case over here, you're not just asked for the derivative of natural log of x. You've got a more complicated expression inside of the natural log function. So in each case here, we're going to have to also apply the chain rule. Derivative of the outside times derivative of the inside. So taking this first example, if f of x is equal to natural log of x cubed minus 4x, then the derivative f prime of x, using the chain rule, will be 1 over everything that's inside. So 1 over the inside times the derivative of the inside. So times the derivative of this x cubed minus 4x, which is 3x squared minus 4. So our final answer is 3x squared minus 4 over x cubed minus 4x. Now, some people like to go ahead and write a rule that incorporates the chain rule with this rule for the derivative of the natural log function. So if you like, rather than thinking through the chain rule every time, we could express this rule as the derivative of the natural log of u, where u is some differentiable function of x, is equal to 1 over u, that's the derivative of the outside, times the derivative of the inside. So that's equal to u prime over u. So some students prefer to memorize that special rule so that you don't have to think through every step of the chain rule. Notice that that would work here. U prime is the derivative of the inside, that's 3x squared minus 4 over u, x cubed minus 4x. For me, it's fine with me either way, whichever way you prefer to think through that one. Now, with these two examples, we could approach it using just the information I've given you so far. So you could do 1 over all of this times the derivative of the inside. Notice that when you differentiate the inside here, that's a fairly complicated derivative in and of itself. You'd have to apply the product rule, and then when you differentiate this part of that product, you'll have to apply the chain rule again. So it's like chain rule within chain rule. In the case where you have complicated expressions inside your logarithm, it helps to apply properties of the natural log function first to simplify the problem and then differentiate. So the properties that I'm referring to, you might remember back from your days in pre-calculus or algebra. If you have the natural log of a times b, that can also be expressed as the natural log of a plus the natural log of b. If you have the natural log of a divided by b, that can be expressed as the natural log of a minus the natural log of b. And if you have the natural log of a to a power, let's say p, that's equal to p times natural log of a. So these are properties of logarithms that are typically taught in an algebra class and or a pre-calculus class. So it helps us to break up a problem like this into kind of separate problems, so two separate problems that are by themselves easier to solve than trying to tack this thing head on. So in this case, this original function is equal to natural log of x plus the natural log of the square root of x squared minus 3. And this square root can be expressed as the 1/2 power, x squared minus 3 to the 1/2. And so we could, and keep in mind, don't get too hooked on this rule, it only works when it's inside a logarithm. But if the expression inside your logarithm is raised to a power, you're allowed to take that power and move it down in front as a coefficient. So this original function y is equal to natural log of x plus 1/2 times the natural log of x squared minus 3. All of the steps that I've applied so far are just using properties of logs to rewrite the original function. We haven't differentiated anything yet. But now that we've kind of dissected this complicated logarithmic expression into separate, simpler logarithmic expressions, then now we're ready to take the derivative. Now we can apply some rules for derivatives. So the natural log of x is just 1 over x. That's just straight from that rule we established early in this section. Plus constant coefficient of 1/2, so that'll just sit there. Derivative of natural log of x squared minus 3. This is a lot like that last example. So it's going to be 1 over the inside times the derivative of the inside. The 2's cancel here, and so our final answer is 1 over x. See, the 2's canceled. Multiply straight across 1 times x, so this is x over x squared minus 3. And it is a lot easier to find the derivative that way by applying properties of logs first than it would have been to just go straight chain rule and then product rule within that and then the chain rule again within that. So take advantage of properties of logs when you can. Last example here. Same way to start out. So we could attack this head on and do 1 over all of this times the derivative of the inside, which you'd have to use the quotient rule for that, or use this property of logarithms that says this original function is equal to, so y is equal to natural log of the top minus natural log of the bottom. And so now we could take the derivative that's equal to 1 over, leave the inside alone, times the derivative of the inside, minus, same deal here, chain rule, 1 over, leave the inside alone, times the derivative of the inside. So in this case the 5's cancel, and this is equal to 1 over x minus 1 over x plus 1. And there's your derivative.